Og vår neste foredragsholder har I mange år vært professor I Civil and Environmental Engineering og Computer Science ved Stanford University. Forskningen hans baserer seg på å forbedre produktiviteten I gruppeprosjekter involvert I å designe, konstruere og drifte fasiliteter, og fremme det bærekraftige I det menneskeskapte miljøet. Hans forskning har blitt brukt av mange små og store industrielle statlige organisasjoner over hele verden, og ikke minst også hans innsikt I kunstig intelligens I design. And it's an honor to give the floor to Professor Martin Fischer. You didn't understand a word what I was saying, so I'm more or less correct, I think. And the title of your speech is Post-Heroic Management Possible in Construction. The floor is yours.
Thank you. Hi, good afternoon. As always, it's a great pleasure to be back in Norway. Actually, I was reflecting the conversations we've had so far today, how far we have come, even though it sometimes seems a bit slow in how we're progressing in our industry. If I look back at one of the first digitalization in construction seminars we had actually in Norway at NTNU 20 years ago. And since then, especially in the last 12, 18 months, I've seen a lot of engagement across companies, from people in the trenches on projects to the senior management teams. And has been the one word I did understand occasionally, it was digitalization. So if you're talking about digitalization, then you are probably talking about post-heroic management. I hope to bring a bit of a management perspective to you this afternoon in terms of the opportunities, and with that, of course, also challenges from digitalization for our industry. Because I'm not against heroes. They achieve great things in our industry, but it's probably not a sustainable business model to rely only on heroes to get your projects to be successful. And that's what we still see in many places around the world. I've had the pleasure for the last 30 years to work in the context of the Center for Integrated Facility Engineering, which is an industry center funded entirely by industry that has focused on these questions of digitalization and its impact in the construction industry for the last 30 years. And as you can see, many companies from Scandinavia are participating in the center. And the one question that is with the top managers across the world now in these leading organizations is, yes, we have great people. And of course, we want to continue to have great people. But is it enough in 10 years to still be competitive with mainly having great people? If that's not enough, though, that means we have to bring some kind of systems, digital systems, into our organizations, and it's not something we really know how to do. That's what I see every top manager thinking about when they wake up at night. So, as I said, in the last few years, a lot of progress has been made. We've had the privilege to participate in that through this virtual design and construction certificate program, where we have worked with numerous of your professionals across Norway to help project managers, project engineers, design managers, etc., think about how can they bring digital methods really into their projects. And here, the most recent group of graduates just a month ago in Sola that learned about how to combine building information modeling with lean construction management methods or project production management with collaboration methods, integrated concurrent engineering, to achieve a greater project success that then help the client be more successful. And it's sort of on this foundation that I want to make my comments. Because as you know, we hear every day about lots of trends. Mobile solutions, cloud solutions, the ability to parallelize work, to get much higher precision very quickly in terms of your location locational dimensional management, the machine learning, artificial intelligence, data analytics, robotics, additive manufacturing, Internet of Things, virtual environments, collaboration technologies, and lean management methods, among maybe a few more. But these are in the news almost every day, and it's interesting to think about the impact of one of them on our work. It's actually really challenging to think about the impact of all of those together on our work. But that's where we really see tremendous opportunities, but that will also bring significant change with itself. And that's what we can do better in a community like the center that I'm leading at Stanford than each of us on our own. So, but given this, when you go back to the office, you will have to decide how to allocate the resources in the organization. So you have to have a way of selecting the most important thing for your people to do in terms of moving towards this future of more digitalization in our industry. For that, I would like to suggest the strategy diamond framework that was developed by my colleague in the business school, Robert Bergelman, that says that internal selection of what you're going to do should be shaped by what it takes to win, which should be contrasted with what is it that you've got in your company. And it should also be shaped by what you say you do, your strategy, and what you're actually doing. Being actually honest with, like, we say we do this, and what are we actually doing? So within that force field, you should select what your organization does to innovate, to improve. And of course, the lower part of the figure is really what you need to do. I can't tell you what to do here, but I can give you a bit of context in terms of what I believe it will take to win in the future, in terms of the industry, the situation you will face. In particular, I believe you will have to make strategic decisions in terms of whether you're offering a product or a service. What is the role of your projects versus what you do at the corporate level? What do you do with your partners? And how do you develop your staff? And I will illustrate these with some examples from projects. So every CEO that I know, and here a few from the sci-fi community, you might recognize some of these faces, every CEO is super proud of the people they have. As I said at the beginning, typically that's one of the first things I hear why people enjoy working in the industry, because we have great people. And so I'm not saying that we get rid of the great people, but I'm saying that we actually respect those great people more by giving them dramatically better tools than what we're giving them today. So it's not the people or the tools, people or digitalization, it's really people and digitalization. And I think there was some spiel or something along these lines that I kept hearing. I believe that's what this means. So we have perfected over the last 50 years in project management the art of dividing and conquering things. And that serves us well to some extent, but it rarely leads to a great project that comes together for the client in ways that he or she really envisions. And so that's why we came up with a strategy to counteract that need to break things up into little chunks of work, so that we can maintain this overall vision of the project. We call it the simple framework for integrated project delivery. So we want to achieve a high-performing building. And to make a building high-performing, we need to really think about how the different systems that make up the building connect, integrate, support each other, are synergistic with each other. To create this kind of web-connected, integrated set of building systems, we need to have the processes, the design and construction processes that create it, connected or integrated, because otherwise it's silly to expect that a set of fragmented processes would miraculously create this integrated, high-performing building. For that, we need to integrate the organization. We need to bring the people together, because again, otherwise, how can they carry out connected, integrated processes? And to support the integrated organization, we need to have integrated information. We need to have information that supports the organization rather than the people working for the information. The information needs to work for for your staff instead of still too often the case the other way around. And to support this, we need to define ways of measuring the value of our buildings. We need to do so by showing with computational methods what a great building looks like. And we need to have methods to bring the people together, to have them work with each other, and to manage their work productively every day. And ideally, we support it with some kind of integration agreement. And because sooner or later, you will pay for the integration. Either you'll pay through poor operation, you will pay it by fixing the rework in construction. Sooner or later, you pay for it for this integration. And we've tried to outline this in this book that recently came out called Integrating Project Delivery, which really brings together experiences for many, many professionals, as you can see, and for many projects with many examples. So I hope you've bought it or will buy it. I'm one of the authors, so a little bit of self-promotion. But it works something like this, right? So we have to define what does the high-performance building actually mean? And by building, I also mean a road or something. How would we know that we've gotten what we want? So we need to define that, and then we can best do this when we simulate, visualize it on the basis of integrated information from the different disciplines that support the organization working together. It's very, very difficult for different disciplines to work together without a great tool. If you don't have a great tool for collaboration, you're left with basically the social ability of engineers to make your project successful. And we all know how good those are, given how many classes they've had in this particular topic. And then the organization can design the best work process to create this set of integrated building systems that is then hopefully high-performing. And of course, we should have an agreement around it. So you can see in the snapshots, in the pictures, many of the things you're using probably already on your projects in terms of management of your projects, in terms of the visualization, the building information modeling, and so on. And so the point is really to bring all of those together and make them, set them up in pursuit of what your clients actually really want. So the integrated information, in my experience, is super powerful to get this started. Like I'm trying to illustrate here with this project from Max Bögel in Germany, where they brought really a lot of information together to give the customer of this shopping center a vision from the detail to how it's going to work in an integrated way early in the project when it was still very feasible to make changes. So we don't only need to create a vision for our projects and show it in vivid ways for our customers, we also should have a vision for our industry and for your company. And my colleague again, Robert Bergelman, has for me the best definition of what a vision is, because it's kind of a big word. And he says a vision is a future I would like to make happen. So what is the future that I would like to suggest we make happen for our industry? I suggest that the future we want is one where every work hour, blue collar, white collar, builds the right product safely and productively. I think when we can say that, we have an entirely new industry that will achieve far greater things for our society, for our clients. We can be really proud to be part of it. And we can imagine probably even better things to do once we are at this level. So I want to show, also coming back to the strategic choices you will have to make, examples of organizations that are trying to define what is the right product, what is the right building, and that are trying to make it created more safely and more productively. So building the right product. Here, an example of a project currently going on in Foster City, which is near San Francisco International Airport, by a pharmaceutical company, Gilead Sciences. The people there are unbelievably passionate about the vision, the mission of the company, which is to bring affordable medication to populations around the world. And so they really want to translate that vision and mission into their buildings and say the buildings we have are critical in our mission. And they realized recently that they actually haven't told their design and construction team how important their buildings are and what specifically they are worried about and or care about. So here is, for one of their current ongoing projects, what they wrote down for their design and construction team. This is sort of the 10 overall goals for each of those to have very specific, quantifiable targets and metrics. I think this is a big progress in the right direction. I won't read every one of them. You can glance through them. This has been one of the surprises teaching this virtual design and construction program around the world. You saw on top was the client's objectives for the project. We have now taught this class at least 60 times over the last 10 years to well over 1,000 professionals. And very few of them could actually say what is the client's objective for the project. It's really surprising. And partly because they didn't ask, and partly because the client didn't tell them. It's really strange why many clients do seem to believe that they get a better project by not telling them what they want. It's like you're getting into a taxi cab and say, I'm not going to the airport. Yeah, that doesn't work, right? So here, at least, this client is trying to tell its project teams what they want, so they become actual partners in achieving that success. Maybe slightly beyond is a project that is still under construction, although the core and shell part is mostly finished now. Very high-profile project, the Tesla Gigafactory. I think this is a rather remarkable project, and I wanted to share this example from the structural engineer's perspective, because that's a rather critical role in the core and shell of this factory. So the part that I will describe is 5 buildings, 3.8 million, 350 to 400,000 square meters, 2-story factory. So it's the core and shell, basically the space that allows Tesla to install the equipment they need to produce part of Model 3 and the Powerwall. They basically panicked last year in early April after so many people ordered the Model 3. And they said, we have to bring dramatically more production capacity online much faster than we ever thought we had to. So they called Greg Luth, a structural engineer, small company, 20 people, and said, can you support us in creating this factory really quickly? So they said, and he said this was April 6, 2016, and he says, yes, well, when do you want the factory, the 350 or 380,000 square meters? And they said, in November. And he said, you mean the design? I said, no, the factory, built. I mean, okay, ready for tool install. And he said, oh, so what is your space program? We don't have it. We are developing it. But we need to order steel. We realize that. And so they basically, they had a slightly longer conversation, but they were able to figure out what are the things that Tesla really valued, and which was the schedule and flexibility to add potentially additional floors, they called so-called mezzanines, if they needed a little more production space. So with these requirements, Greg designed a system, a structure that occupied, where the lateral system occupied as few bays as possible to maximize their flexibility. And a structure where he could late in the process add capacity if it was needed. This allowed him to order 80% of the steel 1 week after the phone call and get things going. And so here is a picture of this innovative lateral bracing system. Here you see a picture of one of the buildings. You can see how many bays are left open. This is a heavy earthquake zone, right, mind you. And in the end, they were able to open the 5 buildings with 350,000 square meters of production space. Design, build, design, order, fabricate, install 32,000 tons of steel, 2,500 tons of rebar for a structure that could accommodate 2,000 kilograms per square meter of load in 7 months from the first phone call. So this was a rather, I think, remarkable achievement. And it was made possible because of a few things. Because they detailed every little piece in the model. They said, we have to be really fast, so we have to be really precise and reliable. Otherwise, we don't have time to fix mistakes. So we have to actually finish the design. We can't take a shortcut here. And they were able to work in parallel. They did the design, the detailing, and the analysis in parallel because they picked a structural system that had some flexibility of making adjustments if the analysis showed more capacity was needed. The sequential process would have not led to this kind of speed, right? And maybe most importantly, sort of some reflections from the structural engineer and coming to this topic of service and product. He says, incomplete design is the source of many problems in our industry. In light of the potential offered by the digital revolution, the traditional design process is an anachronism we can no longer afford. Says, he saw his job as creating a high-performing building, not to create a model or a set of drawings. Yeah, those were needed along the way. And I think that's one of the key mindsets we have to change. We are creating a high-performing building for our customer, not just an estimate or a schedule or whatever. Those things are needed, but you just need to do as much of them as you can. So you've seen here the transition from a service focus, which was also important on Gilead, to a product focus, which was really important here on Tesla. And Tesla, this has created a lot of excitement in the US. The only function they outsourced was the structural engineering. Everything else they took in-house because they said the construction industry was not capable of delivering what they needed. So next thing is, what does corporate do and what do projects do? We're all used to the project manager is king. That seems to be pretty much the culture around the world. But as we look at some of these digital systems, that becomes really difficult to stay with this focus. So this is a scenario that happened a couple of weeks ago in the offices of a general contractor on the East Coast. They'd run a project and created a schedule for it, and it showed a schedule of 567 days. And they were wondering, is this schedule actually realistic? So they used a new tool that has come out of my research group by a company called Alice that totally automates the scheduling process because it encapsulates construction knowledge and basically physics that we need to pursue, meet in the construction process. And so we take a BIM, simplify it, so it just has the information that's needed into a construction information model. And as they simulated it, they said, well, the CPM schedule is actually not accurate because it missed some constraints. This project is not a 567-day project, this is a 622-day project. So then they wondered, what could they do? So they tried, and the system automatically creates a 4D model for every scenario. In every simulation, it looks typically at 6 million schedules because there's lots of different sequencing possible, lots of combination of resources. And so then it automatically creates a 4D model for each of these solutions, which you can then look at. And it puts the projects into this kind of grid where it says, okay, here are a few best solutions for a particular scenario. Here is the duration, here is the cost. So with some resequencing, they were able to get it to 610 days. Then they said, okay, what's the fastest we could possibly build it? So they said, well, let's just put 15 crews of every type on every type of activity. We know we can't use that many, but this will tell us how fast we can possibly build a project. So they found that that is 549 days. And you can see here, it takes a few minutes to make these changes. So they could very rapidly play through different schedule scenarios and eventually find one that actually involved a few extra crews and a bit of overtime that got them cost-effectively back to where the CPM schedule actually thought they could be. So this kind of this is where you see how we can encode information in the computer so the computer can really help the professionals. And the professionals can do what they are good at, and the computer does what it is good at. But this kind of innovation is unlikely to come into your projects rapidly enough if you let each project manager find it on his own. So I think there's some new role between corporate and projects that needs to be determined. And finally, the last point I need to make very quickly, I see the time, is that we need to think about partnerships and staff development. So in terms of partnerships, I want to illustrate this with this example where an engineer with a good connected tool is far superior to an engineer that has just today's tools. We saw this on this design of this roof truss for a soccer stadium, where the engineering team came up with today's methods, with looking many options, with a truss that weighed 2,700 tons. When we connected all those tools, automated the analysis, we were able to look at thousands of options and find one that weighed 20% less. So then, of course, the people very quickly say, well, that's just the weight. We have more cost than just material costs. It's also about fabrication and erection. And so by bringing those together, we saw that a frame optimized for the cost weighed actually 8% more, but was 13% cheaper and 20% faster to get. But this is only possible if you have a partnership with a company that can give you these data. And so that's where we see the use of digital tools, and optimization is a big, big use of those tools, really requiring new kinds of partnerships. And it also requires new kind of staff development. Here, a developer that for this tower in Chicago, over 2 weeks, with one architect and 2 BIM modelers, created 13 options that he studied fully from architectural, structural, and construction perspective in conceptual design, so that he could pick the best option. So you can see this requires quite different people and with different skills on your projects, which this guy has done in terms of restaffing. So I found that post-heroic management is possible if the client actually defines what he wants, if we then actually set up the organization with the expertise to pursue those goals, if we then really leverage what the digital tools can give us in terms of visualization, information, and automation. I tried to illustrate that briefly. And we learn from projects to projects. I think then we can think about how to go to post-heroic management. So hopefully I've been able to show you some examples of what it will take in the future to win in terms of these 4 key categories. Are you offering a product, a service? What is the role of projects versus corporate? How do you work with partners? And what does your staff do? And I think you can see that the mud that will shape the experience of our future leaders in our industry is changing quite dramatically. And so we also have to find a way of recognizing that new mud as we promote our leaders. So thank you for your attention, and I look forward to continue to work with you.
Thank you, Martin Fischer.